All right, 8.6 is talking about probability. You guys have all heard that word before. We hear it a lot with like weather and stuff like that, but we're going to talk about flipping coins and rolling die and then using charts and tables and stuff like that. But you're going to hear words like experiment, outcome, sample space, and event. All right, the outcome is what happens, what you're expecting to happen, what could possibly happen. The experiment is what you're actually doing, like flipping the coin or rolling the dice or whatever like that. And then your sample space. Sample space is what could possibly happen. When you list out all of the things that could possibly happen. Like yesterday we talked about, pairs of letters or something like that. Your sample space would be where you write out every single thing that could possibly occur. So everybody... Okay, you guys understand that? So like in the first one, when they talk about finding sample space, think about what the possibilities are in letter A. You have one coin tossed. Yes? One coin. What does the coin have on it? Two sides. What are on the sides? So your sample space, you would write it out like your sample space is head, tail. It's the only two things that you could get, correct? If you flip a coin. Everybody understand that? What's the probability of you getting a head? 1 out of 2. What's the probability of you getting a tail? 1 out of 2. 1/2. All right, what about if you flip 2 coins? All right, so let's think about 2 coins. The more outcomes you have, the harder it is to list everything. So think about if you have 2 coins. You could possibly flip them and get what? Heads and tails. What else could you get? Heads and heads. What else could you get? Tails and tails. Is there anything else? Tails and heads. Good. Everybody agree with that? All right, what about if we have 3 coins? Think about this. It gets a little more complicated when we have more elements that we're adding, to our experiment. So 3 coins. What are my 3 coin options? I could have heads, 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 right? 3 heads. What about if I had 2 heads and a tails? Yeah? What about a tails, a head, and a tail? What else? Okay, head, tail, head. Tail, tail, head. What about if I had 3 tails? What about if I had 2, 3, 4? Are we missing any? How about 1 tail and 2 heads? That work? All heads, heads. Do we have a heads, tails, tail? Right? 1, 2, 3, 4, 5, 6, 7, 8. Say it again. Heads, 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 head, head, tails, head. Do I have a tail and 2 heads? A tail first and 2 heads? Yep. Head, tail, head. Yep. Tails, head, head. I feel like we're missing one. Okay, so what do you guys notice? The more elements you add to your problem, what? Longer it gets. Is it easy to try and sit here and think of all the different combinations that you could possibly have? No, right? So that's why we use probability. That's why we use formulas. That's why we have mathematical things that come about so you don't have to just sit here and list everything out. Here is the formula for probability. It says in an event E has NE equally likely outcomes and sample space has NS equally likely outcomes and the probability of event E is given by. This is what this means, guys. This is what I want you to write. Probability is what you want over the total possibilities. If you guys can remember that, probability is not going to be so bad. I should write the word probability, not possibility. Or possibilities. P-O-S-S-I-B-I-L-I-T-I-E-S. It's what you want over the total. I'm going to refer to that a million times. Probability of something happening is what you want over the total amount of things that there is. Now, if we're talking about numbers, whole numbers, 0 to 1, This would be like 0%, and 1 would be 100%. Does that make sense? A lot of times you hear percentages in, like I said, weather, that sort of thing. It's 50% chance of rain. It's a 20% chance of this. Sometimes you'll see probabilities written in decimals. If I had this as my decimal, what is that as a percentage? 30%, okay? 30%. If I had this as my decimal, what is my percentage? 90%. So when they talk about the likelihood of an event happening, the closer it is to the whole number 1, or 100%, that's closer to it happening. An improbable event or impossible event that it can't occur would be at 0 or 0%. Do you guys understand that scale? Percentage-wise, the likelihood of something happening, if you're closer to 0, it's less likely to happen. If you're closer to 1 or 100%, it's more likely to happen. Does everybody understand that scale? Okay, all right, moving along. Good job, good job. Write this. Is that already written for you guys? Okay. Probability can be expressed, guys, 3 different ways. A simplified fraction, a decimal, or a percentage. All 3 of those things are interchangeable. Depending upon how the question is presented to you is how you should answer it. If you start off with fractions, you should end up in fractions. If you start off with a percentage, you should end up with a percentage, unless the directions tell you otherwise. So let's look about the probability of events happening, all right? Again, I put in Module 8, because we're going to need this in a second. I put in Module 8 the deck of cards. You guys need to be familiar with the deck of cards. You're not going to think it. You're not going to be getting that on your test. So you need to be familiar with what a deck of cards looks like. So let's look at A. 2 coins are tossed. What's the probability that both land heads up? All right, so let's think about this. Let's look at this. 2 coins, right? You guys agree with me? I have 2 coins. All right, and on my 2 coins, what are the 2 options that I have on each coin? Heads and tails, and heads and tails. You guys agree? Everybody with me? All right, so let's look at our sample space. What are the options? What could possibly occur when I flip my 2 coins? I could have a head, right? I could have a head and a tails. I could have a tails and a head, and I can have 2 tails, correct? Yes? Okay, so the question says, what is the probability that both land heads up? What is probability again? Hi, it's want over total. What I mean by that is, what do we want to happen? We want a double heads, right? We want 2 heads. How many total possibilities do I have when I flip the coins? I have 4 possibilities, right? So look at your sample space. What is the occurrence of both of them landing on? So what is the possibility? How many times does it occur in our sample space that you get 2 heads? How many times? 1, right? Out of how many possibilities are there? 4. Okay, it's 1 out of 4, right? Well, if they asked you to express that as a decimal, Raul, what would that be? 0.25. And then if they asked that for a percent, what would that be? 25%. All right, we need to be able to interchange those answers. You need to be able to answer in a fraction, a decimal, or a percentage. So let's look at B. Again, your standard deck of cards. If you guys don't know, it's in modules. Pull it up so you can see it. But it says a card is drawn at random from a standard deck of playing cards. What's the probability that there's an ace? So think about a deck of cards. There's 52 cards in a standard deck. Does anybody know how many of them are aces? Okay, there's 4 aces. So probability, remind yourself what probability is. It's what you want over the total, correct? So what do I want to happen? What do I want to get? I want to get an ace. And there's a total amount of cards, correct? How many aces are there? Out of how many? Simplify that. 1 over 13? 1 over 13. Now, if you change that to a decimal, you would, in your calculator, if they asked for a decimal, you'd say 1 divided by 13 and get 0.0769. You'd probably ask to be rounded. That'd be about 7 or 8%. But does that make sense? I cannot simplify this enough more than probability is what you want over the total. And if we kind of keep that in our mind, we should be all right here. All right, we're going to talk now about a die or different cubes, number cubes, all right? It says a 12-sided dice, as shown in the figure that I cut off, can be constructed into a dodecahedron, such as the numbers 1 through 6 appear on each die twice. Show that these dice can be used in any games requiring 6-sided dice without changing the probabilities of various outcomes. All right, you're not going to have a question like this in your test. I just want you to see with this, so let's compare, all right? I have a 6-sided die, right? It's the shape, it's a 12-sided shape. Okay, on a 6-sided die, guys, what numbers appear? 1, 2, 3, 4, 5, and 6. 1 on each side, correct? Agreed? Okay. So probability of getting a number on any number, want over total. What's the probability of me getting a 2? How many 2s are on the die? 1 out of how many sides? Okay. What's the probability of me getting a 5? 1 out of 6. What's probability of me getting a 1? Okay. So let's talk about a 12-sided die. Now, what they told me about all we're doing is proving that the probability is the same. What did they tell me about this dodecahedron? 1 through 6 appears what? Twice. So there's 1, 2, 3, 4, 5, 6, but there's 2 of those, 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 right? I have 1, 1, 2, 2, 3, 3, 4, 4. You guys understand that? So want over total, again. The first example I gave was getting a 2, right? What's the example? What's the chances of me getting a 2? 2 over 12, which becomes what? 1 over 6. What's the chance of me getting a 5? 1 over 6. 2 over 12, which reduces to 1 over 6. So the reason that the probability is the same is because the outcomes don't change. They multiplied, but so did the possibilities. So when you reduce the fraction, it just becomes the same. Just want to show you guys that. No big deal. All right, you get a question like this. Again, probability is what? How do we think of probability? Want over total, all right? I told you guys you're going to have word problems, but you're going to be just fine. It says the numbers of colleges and universities in various regions of the United States in 2008, blah, 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 blah. One institution is selected at random. What is the probability that the institution is one of the 3 southern regions? So what do I want to get? A college where? In the southern region. Okay. And what goes on the bottom? All the colleges. All the regions. Good. Well, how do I figure out which ones are in the southern regions? Anybody tell me? Look at the name. What's going to be in the name? South, all right. So what's one of the south ones? West, South, Central. So 406 plus 286. Agreed? Plus 754. Are those all of the colleges that are in the South region? How did you know they were in the South region? Because it says South. Good. And then how do you think we figure out what the bottom is? You add up all of them. Okay, so let's just make sure we add them all up. Can you guys see this? Can you just tell me? I'm going to make it, so I can write. Okay, tell me. Go all the way around. Start with the Pacific. Go to 5. Okay, so I'll do it myself. 581. Then what? 304. Right? 453. Just make sure I don't miss any. 453. Make sure I write it correctly too. 453. Then what? 668. Plus 265. You guys with me? Then 630. 754. 286. And 406. Okay, so but think about this. How did I do this? I figured out what I was looking for. I found out the 3 regions that had the word South in it. I'm adding them together, right? And then how did I find out the whole total? Just add everything up. So what did you get for the want? How many total colleges or universities are in the southern region? 1446. I got 1446 as well. Good. So 1446. And then how many are in the entire country? 4347. I got 4347 as well. Now, when you get here, guys, you have to see how they're asking you to answer it. It doesn't specify here. So I would keep 1446 over 4347. Is that simplified?
No. Actually, yes, it is the ZK.
Is it? I don't know if it is or not. You'd have to throw it in your calculator just to make sure. All right, well, how would I make that into a decimal? Divide. What do you get? 0.3326. All right, well, how would I make that into a percentage?
33.46.
So about 33%. About a third.
So for percentages, you just round it to like the...
It'll tell, whatever you have to do, it'll tell you to round or to do what, the question will specify. The question will specify. All right, we okay? So if you guys get charts, if you get tables, stuff like that, remember, probability is what over what? Want over total. So you look for what you want. If there's a bunch of different things, add them up. And then the total is everything all combined. That make sense? Okay. Let's go on to mutually exclusive and overlapping. All right, the question says, what does the word overlap mean? Like repeat, okay? I agree with that. If something is exclusive, if you and your boyfriend or you and your girlfriend are exclusive, are you overlapping with anyone else? No, okay? So think about it that way. Overlapping events, right? Intersect, we can kind of say like a Venn diagram. Mutually exclusive have nothing to do with each other. Does everybody understand that? Hear that concept. All right, so here are the two probabilities. I understand that you guys are looking at this and you're like, what? If you have an overlapping event, and this is usually 95% of the time, this will be with a deck of cards. They'll ask you, can you get this or this? And then there'll be an event that they're asking you, can you have a black card or a face card? Or are there such thing as black cards that have faces on them?
No.
There's no black kings, black queens, black jack, right? That would be an overlapping event. Mutually exclusive would be you get an 8 or a king. Is there any card in a deck of cards that has an 8 and a king on it? No, so that would be a mutually exclusive. It has nothing to do with each other. So the way that we find this out, you're overlapping. You'd find the probability of the first event happening. The word or in math means to add. Remember that. Or means add. So then you find the probability of the second thing happening. And then you have to subtract the overlap. And I'll show you what I mean by that in 1 second. This is for overlapping events. You're going to find the probability of the first thing, find the probability of the second thing, and then subtract what overlaps. And I'll show you in a second. Yep.
The sign for the overlap is that arc?
Yeah, it's the union between A and B.
And what the one that's the first thing? That means that they're not...
It's the mutually exclusive, the one that has nothing to do with each other, is you take the probability of the first event and add it to the probability of the second. Remember, in math, or means add. So a lot of times, and on your test, you'll see questions like mutually exclusive and overlapping that have to do with a deck of cards. Again, pull up the deck of cards from your modules. You guys have to know what's going on in a deck of cards. The best thing I can tell you to do is write everything down. It says one card is selected at random from a standard deck of 52. What's the probability that the card is either a heart or a face card? First of all, do you see that word or? That means add. So look, you don't have to do this, but I'm just going to show you. I'm going to say the probability of me getting a heart, right? Or the probability of a face card, right? So think about this. At this point, you're not sure if this is mutually exclusive or if it's overlapping. So let's just fill in what we know here. Look at your, if you need to, look at the deck of cards. How many cards of the 52 have hearts on them? Okay, so 13 out of 52. Agreed? Yeah? Okay. Pull up, I'm telling you, pull up the deck of cards so you can see it. There's 13 of each suit because there's 4. How many cards in a deck have a face on them?
12.
Okay. 12 out of 52. Now, everybody in here. Okay, it's best, guys, if you have your deck of cards right in front of you. So let's talk about this. We need to see if this is an overlapping event or mutually exclusive. So the first thing, the probability of getting hearts. Here's my hearts. That's where Camilo got 13 out of 52, right? So then face cards. Well, here's my face cards. Is this an overlapping event or is this a mutually exclusive event? Why is it overlapping?
There's 3 parts.
There are 3 cards that have faces and are hearts. So when you have an overlapping event, you take the probability of the first thing happening, add it to the probability of the second thing happening, and then you have to subtract the probability of the overlap. So I have to subtract, I'm going to write on here, the face cards that have hearts on them, right? So I'm going to take off, God bless you, the 3 out of 52. Now, guys, you're adding and subtracting fractions. They all have the same denominator? Yes. So what's 13 plus 12 minus 3? 22, okay. Can I write that as a simplified fraction? 11 over 26. What would that be as a decimal? 11 divided by 26. 42.3, so 0.423. And then as a percent, that'd be about 42%, right? You guys need to become familiar with a deck of cards. I promise you, it'll be on your test. What about if I said, let's just do another one. Let's do the probability of an ace or the probability of a king. Is this an overlapping event or mutually exclusive? Why is it exclusive? There's no aces that are kings. To ask yourself that question when you read it, go, are there aces? When you say it out loud, you're like, oh, that doesn't make sense. So this would be 4 out of 52 are aces, right? Plus 4 out of 52 are kings. So it's a total of 8 out of 52. Can we simplify that? 8 divided by 4 is 2. 52 divided by 4 is 13, right? So 2 divided by 13, if they ask for a decimal, would be 0.15, which would also be 15%, right? Agreed?
Yeah.
Okay, you guys are good. All right, next page. I like this stuff a lot better than yesterday. Combinations, permutations can get confusing. All right, this is very simple, guys. This is very similar to that chart we just did about the colleges in the nation. You just have to read. All right, we need to read what the question says. It says an employee is chosen at random. What's the probability that an employee has? All right, here is the information that they gave us. Do you understand? On the left-hand side, it's the year's experience. On the right-hand side, it's the number of employees that have those years of experience. So the first question, A, has 4 or fewer years. So it's want over total. So what I want is 4 years or less, right? And then on the bottom is our total number of employees. So look at what we have here. How many employees have 4 years, or less? 157, right? 157. Out of how many? Well, what do I have to do with all of those numbers of the number of employees? Add them up. Add them up. What is it? What's the total? What'd you get? So 529 is the total. So everybody see how I got that? Right? I took what I was looking for, put it over the total. So if I wrote that as a decimal, it's 0.269, which is about 0.30. What is that as a percent? 30%. What? Oh, I wrote it backwards. I'm sorry. 96. It was 0.296. All right, B. B is asking me for 9 or fewer years. So want over total. 9 or less over total. Well, we already know what the total is, right? The total didn't change. It's still 529. How do I figure out the 9 or less?
You add them.
I add 157 and 89. 157 plus 89, and I agree, 246. And then that gives me 0.465. So about 0.47, which is about 47%. But again, probability is what over what? Want over total. Okay, we're almost done. You guys are doing great. All right, what did I tell you that or means? What does or mean? You add, So we're going to learn another vocabulary math word, which you guys already know. But when you see an and means to multiply. All right, and means to multiply. So we're talking about independent events. If something is independent of something else, one has nothing to do with the other. Everybody understand that? When I see and, when we're talking about independent events, we're going to multiply. We're going to multiply. A lot of times we see this with lovely die. All right? A lot of times we see this with dice or numbers generated randomly, that sort of thing. It says a random number generator in a computer selects 3 integers from 1 to 20. What's the probability that all 3 numbers are less than or equal to 5? Well, let's think about what we have here. What do we want over total? What do we want? Numbers that are what? Less than or equal to 5. So 5 or less, correct? Yeah? Over the total, okay. So if the numbers are from 1 to 20, how many of those numbers are 5 or less? 5, 4, 3, 2, and 1, correct? So there's 5. How many total numbers do I have from 1 to 20? 20. Okay, so what's the probability that one time I'd get a number that's 5 or less? 1 over 4. Agreed. So the question says, what's the probability that all 3 numbers are less than or equal to 1/4? So I'm generating a number, and I'm generating another number, and I'm generating another number. Do you guys see that? It's not or. I want all 3 of them to be the same. So and means to multiply. So what is this going to be? 1 out of what? 4 times 4 times 4. 64. Not 4 times 3. 4 times 4 times 4. If it said that you did it 3 times and it was the first time or the second time or the third time, then we would add. But since we're getting and all 3 of them are less than or equal to, that means 1 and then the next one and then the next one. You multiply together. Does that make sense? All right, last thing I want to talk about is marbles. You guys have this on your notes, right? If you downloaded your notes before yesterday, then you don't. I forgot to add this on the last part. You guys will have marble questions on your test. Again, you have to read. Do you guys see these 2 questions? How are they different? And or. So and is going to ask you to do what? Multiply. Good. Or is going to ask you to add. All right, these marble questions are easy. You just have to read. 2 things you got to pay attention to. And or. And with replacement, without replacement. If you have 10 things in a bag, we talked about this with the numbers yesterday in a box. 10 things in a bag. And you pull one out, look at it, and you replace it. The second time I put my hand in the bag, how many are left in the bag? If you start off with 10. If I replace it, it says with replacement, you put the marble back in. There's 10 marbles in a bag. I take it out, I look at it, I say, oh my God, this one's blue. And then I put it back in. How many are still in the bag? 10. If the question says without replacement, I have 10 marbles in a bag. I take out this blue one, it's so cute, and I give it to Gigi. How many are now left in the bag? 9. All right, when we're talking about probabilities, guys, your denominator is 10 to start off with because there's 10 marbles. If I put the marble back in, your denominator stays as 10. If I take it out and give it to Gigi, your denominator does what? Changes to what? If there was 10 to begin with and I gave 1 to Gigi, what does it become? 9. Very important that you pay attention to that because it will change the math in your problem. This first one says you have 8 marbles in a bag. 4 are red, 2 are green, 1's yellow, 1's black. And it says without replacement. What does that mean? Without replacement. Do I put it back in the bag or I don't put it back in the bag? So write down, don't put back. Something like that. So what's the probability that 1 is red and 1 is yellow? So let's think about it. How many total marbles do I have in the bag to begin with? It says 8. If it didn't say it, you would have to add them. So it says 8. So the first chance I have a total of 8. How many of those 8 are red?
4.
So 4 out of 8. Everybody agree? Okay, then I see the word and, so I put a multiply sign. Now, you are always assuming that the marble you took out is the one that you wanted. All right, so I reached my hand in, I got a marble, and what did I do with it? Did I put it back in, or did I just set it on the counter? Set it on the counter. So how many marbles are left for me to go in and grab? 7. And I want to get what color? Yellow. Well, how many of them are yellow? 1 out of 7? Okay. So how would I figure this out? You multiply 4 over 56, which would reduce to what? What's 56 divided by 2? 28. All right, what's 56 divided by 4? 1 out of 14. All right, what would happen, guys, if I wanted red again? My first probability was 4 out of 8. What would the second probability be? If I wanted 2 reds. How many out of 7? I started off with 4. So you assume the first one I took out was red. I gave it to Gigi. Well, how many are left in the bag? 7. And how many of them are red? 3. If you wanted the same. If I want black or red, okay, think about it. I'm not replacing. So how many are in the bag? There's 8. How many of those are black? 1 out of 8. What does the word or mean? Okay, I did not put the marble back. So how many are left in the bag? 7. And how many of the ones that are in there to begin with are red? Can I just add those together now?
No.
What do I have to get? Common denominator. What's the common denominator between 8 and 7? All right, so 56. If I change this to 56, this becomes a 7. If I change this to 56, this becomes what? 32, okay. So then I have 32 plus 7, which is what? 39 out of 56. Does that reduce? No, it doesn't. I'll help you out. All right, last one. What's important about this problem? What does this say? So what is the denominator every single time? 8. It's the same. Okay? If you replace, your denominator stays the same. If you do not replace, your denominator goes down by 1. Just try to visualize it. All right? I have and, which means to do what? Multiply. And I have or, which means to add. Write that down so you don't forget. So let's look at this problem. I want 1 red and 1 green. So how many of these marbles are red? 4 out of 8, right? I replaced it. I looked at it and said, oh, good, I got it. And then I put it back in, so there's still 8. And then how many greens do I have? 2 out of 8. So 4 times 2 is 8 over 64. What does that reduce to? 1 over 8. Good. Now when we have and, we multiply. When we have or, we do what? Add. So again, this time I want a green or red. So 2 out of 8 are green plus, how many reds? 4 out of 8. So what does this become? 6 out of 8 because the denominator is the same, we can just add across. So then this becomes 3/4, right? Questions? A lot of this stuff, guys, is just very small semantics. That's why I wanted to get through this. Now we're going to practice Friday. I'm going to give you a bunch of problems to work with over the weekend. And then Monday, Tuesday, we're just going to go through these problems. I will do them with you in class. We're going to just go through them. We're going to talk through them, see what you guys are thinking, what you're seeing, and how we can iron this all out. Sound good? Yep. Okay.